Morning, grade 7. Today we're going to continue talking about rate and ratio, but we're going to talk about it in specifically proportion. So proportion is actually an equation that shows that two ratios are equal. So earlier we were talking about like this. We would say that 1/2 equals 2/4. So we would call those equivalent ratios. But now we're going to learn another word for it, which is proportion. So these two ratios are equal because, again, look, I can go 2 times 2 is 4. What I do to the bottom, I must do to the top. And 1 times 2 is 2. So these ratios are equal, but then we can also say that they're proportionate. Remember, another way to check if two ratios are equal is to use cross products. So cross products, I go across and I multiply. So then I could do, well, 1 times 4 equals 4, and 2 times 2 also equals 4. So because my cross products are equal, then I know that my entire equation or both my ratios are equivalent or they're proportionate. So often we talk about proportion, we can think about pictures. If you think about a picture, even if you're looking at a picture on a phone or an iPad, you can use your fingers to make the picture bigger. So here I have two pictures of dogs. They're the same picture, but one's bigger than the other. But they are proportionate. When I look at the dogs, I can see, even though my picture gets smaller, it still looks like a normal picture of dogs. Because what's happening as I'm moving these dogs in and out is I'm increasing my width and my height at the same time. So this part's increasing and this part's increasing. But now take a look over here where I have the question, are these pictures proportionate? So right over here is my original picture. But now obviously if we look at this picture right over here, we would say it's not proportionate. If you look at the dogs, they're squished. They've gotten really tall and skinny. So I've increased the height, but I didn't increase the width. Whereas on this picture, I really increased my width, but then not my height. So I would say they're not proportionate. So again, I can show you, I can move out and I can make it look a little bit more proportionate, or I can make it even less proportionate. So when I'm talking about proportion, I'm talking about equivalent ratios, which means when I'm working with a picture, like let's say this one, I need to increase my height and my width by the same number. So when I drag this out, it normally just does that for me. I drag out on the corner. But if I just move the side in, I'm not increasing things proportionately. It's out of proportion or improportionate. So often we think about proportion when we think about pictures. You can also think about it on a map. Everything's in proportion. So everything's smaller on a map, obviously, than like the actual city, say, of St. Catharines is, but it's proportionate. So let's again take a look at these dog pictures. These pictures are proportionate. So let's say this side of my dog picture is 2 inches and this is 4 inches. And then this is 4 inches and this is 8 inches. I can show you that they're proportionate by writing the width and the height as a ratio. So here we go, 2/4, right? This is my height, we could call it, and this is my width. I'm saying that that is proportionate or equivalent to 4/8. So when I went from this picture A to picture B, I increased my height and width by the same number. In this case, I can take a look. I increased both of them by 2. So because I was fair and equal and I increased my height and my width by 2 for both of them, then this picture over here is still in proportion. So that's what we're talking about when we talk about proportion. Now let's take a look at a few examples where we're just working with numbers. We don't have pictures. And we want to ask ourselves the question, are these two ratios proportionate or are they equivalent ratios? Now I know we like to do this. So we like to go, okay, well, I can ask myself, what did I do to the 7 to get to the 14? Well, 7 times 2 is 14. So then I can check, did I do the same thing on top? Did I multiply by 2? 3 times 2 is 6. I did. So because I've increased them both by 2, the top and the bottom, I can say yes, they are equivalent, which means I can say yes, they are proportionate. Now, if you like this method of thinking, what did I do to one number to get to the next, that's totally fine. But I want to warn you that sometimes that's not going to work. Let me give you an example over here. So when it doesn't work, so if you look here, if I want to think, 8 times what is 11? I'm sure there obviously is a number, 8 times something is 11, but it's not an easy math fact that we've worked with. So when you get to a question like that, in that case, I would use cross products. So remember, cross products, we look across and we see, if looking across, if those products are equal. So I can go down here and I can say 5 times 11 is 55. And then I do 8 times 6 is 48. So because these are not equal, that means up here, this is also not equal. They're not equivalent ratios. And then I would say they're not proportionate. So part of your lesson today is figuring out, are two ratios proportionate? You may use this method, but at least twice, please try and use cross products, because that's going to be coming up in more and more of our lessons. All right, the second part of your lesson is trying to solve a proportion using algebra. Remember how in one of our last units, I think it was unit 4, I said algebra is going to keep coming up. It does. It comes up over and over in grade 7. So we just got to get used to using it. So here we have a proportion, 12 over 5 equals n over 10. We don't know what n is. Now again, grade 7, I'm sure a lot of you are looking at it and go, oh, Ms. Nayab, I already know the answer. I know that I went 5 times 2 is 10, so then I need to do the same to the top as to the bottom. 12 times 2 is 24. That's great if you know that, but just like any other time we work with algebra, I want you to learn the steps so that when we get to more complicated problems where you don't just know the answer, you know how to do those steps. So let's take a look at the steps. The first one is to write cross products. So we're going to go across. So my one cross product is, let me erase that, give myself a bit more room, is 12 times 10. But remember what I showed you on the other screen, my cross products need to equal each other. So 12 times 10 is actually going to equal, let me see if I can move this out of the way. Oops, nope, that's not going to work. Sorry about that. I'm going to write a little bit smaller. This is when I wish that I had my whiteboard back. Okay, so let me write a little bit smaller. 12 times 10, that's one of my cross products, right, from right here, is going to equal the other cross product because I'm going to make them proportionate. So I know that they're going to equal each other. So 12 times 10 actually equals 5 times n. So that's step 1, where we're going to write the cross products. The next step is to simplify. So simplify, I want to get down to one number. So what is 12 times 10? Well, 12 times 10 is 120. What's 5 times n? Well, algebraically, I can just write it like this, 5n. So that was simplifying. Okay, we got one number really on each side. Now the last step is to isolate and solve. And remember, isolate means to go by yourself. So we want to get that letter n all by itself. We don't care what 5 n's are. We want to know what 1 n is. So just like in our unit, on unit 4 in algebra, we say, well, what's happening to n? What's happening is right now it's being multiplied by 5. So I'm going to do the opposite, and I'm going to divide by 5. Remember grade 7? This dividing by 5 here, that's the new thing that's happening. So if I do it to one side, I must do to the other. So again, the new thing is to divide by 5. Then I can cancel out because 5 divided by 5 is just 1, which leaves me with plain old n. Then I can do 120 divided by 5. You can do long division if you like, but I happen to know that the answer is 24 because I can do that in my head. So all of that grade 7 is to go way back up here to show that 12 over 5 is the same as 24 over 10. So again, this is where you are solving a proportion. You're solving a proportion. You're trying to figure out what is this n. So let's do another 2 examples just to help you get the hang of it. Okay, so here we have another one. So we're going to follow the same steps as before. The first step is to write my cross products. So I get 5 times 3.2 from over here. And then from over here, I get 16 times n. So then I'm going to simplify this side. If you want right away, grade 7, you can just write 16n. I'm just showing you where you got it from. Now, 5 times 3.2. Remember, you can always go to the side to do your multiplication. When we multiply with decimals, remember we just move the decimal out of the way for now, and we just do regular old multiplication. So 2 times 5 is 10, 5 times 3 is 15, plus 1 is 160. But then because we moved that one decimal out of the way, we need to move it back in. So my answer is 16. So I end up with 16 equals 16n. So I ask myself, what's happening to n? Well, it's being multiplied by 16. So I'm going to divide by 16. I'm going to do the opposite. What I do to one side, I must do to the other. So 16 divided by 16 gives me n all by itself. And then 16 divided by 16 on this side gives me 1. So actually, over here, n equals just the number 1. All right, let's do it one more time. My screen will come up. All right, so again, same steps as before. I'm going to write 12n. I'm going to put n on this side for now just to get us used to both things. So 12n equals 3.2 times 7.5. 12n. Remember grade 7, I'd never have more than one equal sign on each line. They always line up with each other. Then I'm going to go over to the side to do 3.2 times 7.5. And I get, that is 0. By the way, I didn't mention it, but I've of course moved my decimal places out of the way. 7 times 2 is 14. And then I get this. Then I'm going to add them up. Hopefully I'm doing all my mental math correctly. Then because I move my decimal place out twice, I'm going to move it back in twice, and I get the answer 24. So 12n equals 24. Ask myself what's happening to n. It's being multiplied by 12, so I do the opposite and divide. Remember, this is the new thing, so don't write multiplied by 12 on the other side. I need to do the new thing over here to be fair. 12 divided by 12 leaves me with n all by itself, and 24 divided by 12 equals 2. Now, grade 7, if you want, we go back up here. You also should just be able to look at these proportions and sort of estimate if you're on the right track, right? If you think, oh, 7.5 out of 12, it's about 3/4 or 2/3, and then 2 out of 3.2 or 3 2/10 is around the same too. If you were to end up with, like, let's say you ended up with, you did something wrong and you ended up with 1/12 equals 9/10, you should be able to look at that instinctively and visualize something like a chocolate bar or a pizza, and you should know that 1/12 is not anywhere close to 9/10. So it's just good when you get an answer to go back and think, okay, does that kind of make sense? Am I on the right track? And then you can trust your math skills. All right, that's the end of today's lesson. Feel free to message me on chats if you have any questions. Oh, I never know how to get out of here. I had to push the home button. Oh, sorry, making the movie longer. All right, there we go.